Hello pre-calculus, this is our lesson on hyperbolas. So first perhaps you'd like to know what a hyperbola is. We've talked about ellipses. Ellipses come in this form. An x squared term plus a y squared term with different denominators which give you the minor and major radii. Hyperbolas are what you get if you subtract instead. So looking at these graphs, if you can see them, there. All right, this blue graph in the center, and the color's a little hard to see, but this blue graph in the center is what you get if you solve this for y and put it in the calculator. Oops, sorry about that. So that's the ellipse in the center. If you change that addition to a subtraction, that gives you a hyperbola, and that's this black thing that's touching the sides. If you make it negative, if you make it minus, but you switch the order, you get this magenta shape that's coming in from the top and the bottom. So the hyperbola is, remember we talked about conic sections as being what you get if you slice into a cone in a certain way. So if you imagine the two cones balanced on top of each other, a hyperbola is what you get if you take a vertical slice. That is a curve and another curve. The definition of a hyperbola. You remember, I hope, that the definition of an ellipse is a set of points such that the sum of the distances from any point x, y, the distances to the two foci always add up to the same number. So for any point on the outside, if you add up the distance to the nearest one, the distance to the farthest one, these will always add up to the same number. With a hyperbola, they always subtract to the same number. So when you're looking at a hyperbola, let's look at one of these on the back so you can see a little better. If I pick a point, the foci, which we're not going to talk about today, we'll get to them probably tomorrow. The foci here are more or less here, I'm not quite sure. And if you take a point and do this distance minus this distance, or maybe take this point here, or this point here. If you take the longer distance to a focus minus the shorter distance, you're always going to get the same difference. And that's the definition of hyperbola. To graph them, they're basically the same things we did with ellipses. So we're going to graph the center and find the 4 points the exact same same way we did for an ellipse. So the center of this is at 0, 1, 0, 1. Under the x squared we have 9, so square root is 3. So we're going to go left and right 3 points. So from the center I'll go right 3 and make a point, go left 3, oops, that's 4, sorry. Go left 3 and make a point. Up and down, under the y we've got 16, square root of 16 is 4. So I go up 4 and make a point, down 4 and make a point. That all is the same as with an ellipse. Instead of making an ellipse, I'm going to make horizontal lines through these top and bottom points, vertical lines through these points on the side, and extend them until they meet. The point of this is actually just to get these corner points, but we usually just draw the box. So you'd make a box out of those points you just made. This is going to provide us with the asymptotes. Just trust me, it'll all come together later. You draw basically dotted lines, asymptotes, going through the corners. So make an asymptote there, make a dotted line there, and another dotted line here. They don't have to be perfect. Those are the asymptotes. That is these diagonal lines that these curves will get closer and closer to but never cross. That's what we've just made. Now finally we're ready to draw the hyperbola itself. To do that, you decide whether it's going to open horizontally or vertically. In a hyperbola, one of these will always be positive and one of them will always have a minus sign in front of it. The one that doesn't have a minus sign in front of it, the one that's positive, tells you which way it opens. Here, the x squared term does not have a minus in front of it, so this is going to open horizontally. So I take the horizontal vertices, that'll be the, oh, there's a name for this, well, the vertices of the hyperbola, and then I make a curve that approaches but never crosses those asymptotes I drew. So curves like that, sorry that wasn't very good, and over here, getting closer to curving out toward but never crossing the asymptotes, and that's it. That is your hyperbola. In a hyperbola, only two of these are actually vertices because only two of them are considered part of the hyperbola. So that's these two. In a vertical, so here, these are the vertices. In a vertical hyperbola, these would be the vertices, the up and down ones. I'm going to skip down here. As you can see here, we've got the y squared term first. That's the positive one here, and the x squared is the negative. So here, it's going to open vertically instead of horizontally. Otherwise, things are the same. My center point, I'm going to take this and this. So x plus 1 squared means the x coordinate is at -1. Y minus 1 squared means the y coordinate is +1. So the center is at -1, 1. I'm going to go left and right 4. And up and down 3. Draw the box. Draw the asymptotes. I usually draw them dashed. It doesn't matter. You can draw them as solid lines. And then remember, this is vertical, so my hyperbola goes on the top and bottom rather than on the left and right of the box. So there is my hyperbola. My vertices are these points here. So that's -1, +4, and -1, -2. And those are my center point and my vertices. To put in standard form, the steps are all the same as for ellipses, but there are a couple of details you need to look out for. So I'm going to do number 3 here. As you can see, the x squared term is negative, so this is going to be a vertical ellipse, or vertical hyperbola, and in order to make this come out nicely, I'm going to want to put the y terms first. So 9y squared plus 144y minus 16x squared plus 32x equals 16. That's the grouping step. Now we factor. 9 times y squared plus 144 divided by 9 is 16. Now here, we're going to factor out a -16. This is one of the places where it's a little tricky with hyperbolas. Factoring out a -16, 32 divided by -16 becomes -2. That's always going to happen with hyperbolas. You're always going to have one of these where you have to factor out a negative and it changes the sign. So be aware of that. It's going to come up over and over again. Equals 16. Just like with ellipses, when we complete the square, we're going to have to include that leading number. So I put it in right now. And here the leading number is -16. Now complete the square. That means cut this in half and add the square. So we're going to add 9 times 64. Minus 16. Cut it in half. Add the square. So I put a 1 here. 16 plus 9 times 64 minus 16 times 1 equals, oh dear, do I remember? 576. Yeah, 576. And then the last step, just like ellipses, you divide everything and you reduce your fractions. So y plus 8 squared over 64 minus x minus 1 squared over 36 equals 1. So we have a hyperbola centered at 1, -8. that goes left and right 6 to make the sides of the box, up and down 8 to make the sides of the box, and then opens vertically because it's the y term that's positive and the x term that's negative here. Last thing, if you're given the graph and asked to write the hyperbola, this is actually really simple. This is opening vertically, so I know I want my y term first. The y term's the positive one, the x term's the negative one here, because it's vertical. Here it's horizontal, so the x term would be the positive one, the y would be the negative one. The center is at 0, 2, so this is y minus 2 squared, and x minus 0, which is just x squared. And finally, to get to the sides of the box, I'm going up 2 squared is 4, and left and right, and the box is actually given to you, you have to squint sometimes, but 1, 2, 3, 4, 5. 5 squared is 25. That's the equation. That's it. I'm going to go ahead and give you the answers to the rest of this worksheet. I would like you to pause this and try them by yourself, and then just come back and check them. Okay, I'm back. Here are the answers. To the front side, x side is positive, so it'll be open horizontally. Center is at 3, -1. Vertices are at 5, -1, and 1, -1. And it opens horizontally. Number 10, it opens vertically because the y is the positive term. Center is at 2, 0. It goes left and right by 3 and up and down by 3. Opens vertically. So the vertices are the points at 2, 3. Oh, sorry, at 2, 3 and at 2, -3. On the back, this one is, I know it's a little weird because it doesn't seem like there's anything to factor out, but you do have to factor out that negative, so do not skip this step. Here, it turns out that these have the same denominator. That doesn't happen in ellipses because it would make it a circle, but it often happens in hyperbolas. So this would have a center at -9, 7. It would go left and right by 10, up and down by 10, and it would open vertically. Here, this would have a center at 5, 4, left and right by 6, up and down by 9, open horizontally. Here, so that's a 10. Center at 1, 10, left and right by the square root of 15, up and down by the square root of 10, and it would open vertically. And down here, because this opened horizontally, my x term is first. The center is at 0, 1, so this is x squared over 25 minus y minus 1 squared over, and it goes up and down by 4, so 16 equals 1. That's everything. On the homework is page 650, 15 through 26. I don't want you to do all of what it says because some of it we haven't gotten to, and we'll talk about it tomorrow, the foci and asymptotes. So what I want you to do is graph the hyperbolas and then give us the coordinates of the center point and the vertices. Remember, the vertices are only those two outer points that the hyperbola actually touches. And that's it.